Riemer-Tiemann reaction. Riemer-Tiemann reaction. Riemer-Tiemann reaction. This Riemer-Tiemann reaction involves treatment of phenol with chloroform CHCl3 in aqueous NaOH around 60 degrees Celsius, followed by acidification. We get orthohydroxybenzaldehyde. This orthohydroxybenzaldehyde is also known as salicylaldehyde. Salicylaldehyde. So this is the Riemer-Tiemann reaction. Now let us check the mechanism. First step, this phenol reacted with this base to form a salt, phenoxide ion plus water. Sodium hydroxide to sodium phenoxide. It simply forms as sodium phenoxide. Next step, this chloroform, which is CHCl plus alkali OH minus, being it CCl. This H plus is taken by this OH minus H2O will convert to CCl3. Next step, this CCl3 is converted to dichlorocarbene by the removal of Cl minus. Shifted to here, Cl minus. This is dichlorocarbene. Dichlorocarbene. Then this phenoxide, then react with this dichlorocarbene. This dichlorocarbene behaves as an electrophile because it is electron deficient. So here this net charge shifted to here, this pi electron shifted to here. Get Cl. Here one H hydrogen is there because C hydrogen is there. Here next step, this shared pair of electron shifted to here, and this H plus is attached to here and shifted to here. Is it? Yes. CHCl. Next step, this minus Cl plus excess NaOH, it will convert it to minus CHOH. This OH is two hydroxyl groups on same carbon atom is highly unstable. This condition is highly unstable. That's why there is a removal of water molecule by shifted to here. This minus H2O. Minus CHO. Then this one on acidification minus H plus. This is orthohydroxybenzaldehyde or salicylaldehyde. If we use carbon tetrachloride in place of chloroform CHCl3, this reaction will form salicylic acid. If we use carbon tetrachloride, CCl4 in place of CHCl3 followed by acidification, we get salicylic acid. So this is the Riemer-Tiemann reaction and its mechanism. If we use carbon tetrachloride in place of this CHCl3, the reaction will result orthohydroxybenzoic acid. So this Riemer-Tiemann reaction means a reaction of phenol with chloroform in presence of sodium hydroxide at 60 degrees Celsius followed by acidification, we get orthohydroxybenzaldehyde or salicylaldehyde. This is Riemer-Tiemann reaction. Next, Kolbe reaction. It is also known as Kolbe-Schmidt reaction. Kolbe reaction or Kolbe-Schmidt reaction. This reaction involves the treatment of sodium phenoxide. With carbon dioxide at 125 degrees Celsius under 6 atmospheric pressure followed by acidification we get salicylic acid. So the Kolbe reaction means treatment of sodium phenoxide with carbon dioxide at 125 degrees Celsius under 6 atmospheric pressure followed by the reaction with acid. It will give salicylic acid. Now let us check the mechanism of this reaction. Let us check the mechanism of this reaction. Yes. Plus carbon dioxide. This shifted to here. You get double bond O, C double bond O minus. This Na plus taken by this one, Na plus. Here H plus is there. Next step is shifted to here. This H plus will attack here. And get OH, C double bond O, Na. Next step, acidification. We get salicylic acid. Or orthohydroxybenzoic acid. This is salicylic acid or orthohydroxybenzoic acid. This is the mechanism of Kolbe reaction or Kolbe-Schmidt reaction. Liebermann's nitroso reaction. Lieberman's nitroso reaction. Lieberman's nitroso reaction. When phenol is treated with sodium nitrite NaNO2 and concentrated sulfuric acid, it develops a deep green or blue color which turns red on careful dilution with water. Basification of this solution with sodium hydroxide brings back to this green or blue color. This reaction is known as Lieberman's nitroso reaction. So here in this first step, phenol is treated with NaNO2, it is sodium nitrite, NiTrite, and H2SO4, concentrated H2SO4. It will form para-nitrosophenol. Para-nitrosophenol. And double bond O. This para-nitrosophenol then tautomerizes to quinone monoxide. That means shifted to here, shifted to here, shifted to here. Get double bond O, double bond N, OH. This H plus is attacked here. OH. This is quinone monoxide. Quinone monoxide. Quinone monoxide. This quinone monoxide condenses with another molecule of phenol. Next, this bond O, double bond N, OH. Here, this H bond is attacked here, and H plus and this minus H2O. We get an indophenol, but there is a presence of H2SO4. We get OH and double bond H plus SO4 minus. This is deep blue color. Then dilution, excess dilution with water. Dilution with water. The concentration of H2SO4 is reduces. Then it's turn to red color. Double bond turns to red color. Then when we add basification with sodium hydroxide, then we get sodium salt of this compound, that is, this is indophenol. Basification with sodium salt of indophenol, that is Na plus O double bond. This is on blue deep blue color. Is sodium salt of into phenol. So this is Liebermann's nitroso reaction. Liebermann's nitroso reaction. Here, phenol is treated with sodium nitrite NaNO2 and concentrated sulfuric acid. It develops a deep blue or green color, which turns to red on careful dilution with water. Basification, that is basification with this soda hydroxide, brings back the blue, deep blue color or deep green color. So this is Liebermann's nitroso reaction. Phthalein reaction. In this reaction, phenol is heated with phthalic anhydride in 2:1 ratio in the presence of concentrated sulfuric acid to form phenolphthalein. So here phenol, 2 molecules of phenol is heated with phthalic anhydride. This is phthalic anhydride. Heated with phthalic anhydride in presence of concentrated sulfuric acid. We get phenolphthalein. With phenolphthalein, you get phenolphthalein. So actually what happens here is H, a removal of water molecule from here. This is Phthalein reaction. In this reaction, phenol is heated with phthalic anhydride in the ratio 2:1 in presence of concentrated sulfuric acid to form phenolphthalein. So this is Phthalein reaction.